our webinar on system design using the SG33CX inverter, which is the smaller of the three that we are supplying for now. So I think we have done some bit of background in the past few weeks on what Rand SunGrow is and how capable our inverters are. And we've also looked at some of the supporting accessories that come with these inverters. Right, today we just want to look at how to do a design of a system in terms of what you can do and what you can do, what you can do and what you can't do. All right. We are also going to look at some of the limitations of choosing certain ways of design, right? People design differently, but there are certain things that you might find to be a challenge if you do in your design, right? So just for a start, I'm just gonna start by sharing the datasheet of the 33CX. On my datasheet, I think you can see I've got 3 inverters there, but we'll focus on the 33CX. Right, so you can see that the 33CX has got a maximum PV input voltage of 1,100 volts, of which in South Africa we are only allowed to use as much as 1,100. So assume we have got 1,000 volts. Right, and the startup voltage is around 200, 250, somewhere there, and nominal is 585. The MPPT opens up at 200 volts, and the maximum is 1,000 volts. And you can see that the 33CX has got 3 MPPTs, meaning to say, and each input has got each MPPT has got 2 inputs per MPPT, which means this can take up to 6 strings of panels. That is very, very important. And then the input current is 26 amps per MPPT. And then the DC short circuit current is 40. Also of importance here is to check this value here. You can see that although it's a 33 kVA, that is just a nominal value, it can go up to 36.3 kVA. Right. And in that regard, let me also share something here that is of importance. Let's see. I just want to share my screen here on the PVsyst. Okay, so what happens is when I get into PVsyst, I don't know if you guys can see my screen there. Okay, seems like I can't share this on the PVsyst. Okay, but what I wanted to show you was to say, if we go to the, let's just go back to, and I'll explain using the data sheet. I'll explain using the data sheet then. What I wanted to say is, all right, this, if you check on most of the professional software, especially PVsyst that we are using for now, you'll see that the highest efficiency, they've given us about 3 voltages. You can use this inverter at 500 volts, or you can use it at 585 volts, the input, or you can use it at maybe you can start, let's say the minimum you can start with is 550. You can use it at 585, you can use it at 850. But studies have shown that even when you do the designs, it has shown that when you have got the medium voltage of around 585, that's when you get the highest efficiency, which is around 98.6%. Right. So it's very, very important. Most people would say there's no problem as long as I'm within the range. The range, of course, is a determining factor, but be careful about the efficiency of your inverter. When you find your inverter below a certain value, the efficiency also goes down with that, or above a certain value, it goes lower. Okay, so normally if you can start around 585, 600 volts, somewhere there, it has got the highest efficiency. All right, so let's go ahead and see. Let me just share again our configurator there. Can you guys see my Excel page there? Okay, all right, so this is the configurator that we have built here at Udeco Energy. It behaves more or less like your professional softwares, like your PVsyst and your PVSol that you use on a daily basis. Of course, with some limited functionality. This is meant to make sure that our work is very easy as designers. Those who are going to be doing projects, it must be very easy for you to just come up with a system in a matter of minutes without having to go to attend a course to do the designing. All right, so that is the whole motive of having a configurator like this one. And if you are going to follow this properly, you would see very well that it is very close to the values that all those professionally designed softwares would give you in terms of strings and other values and everything. You see it's very, very close. There are very, very small margins, so you can actually rely on this, right? It is something that we have put our energy into designing, which we think you guys would enjoy, and you'll find it to be very useful to you. Okay, so this is my page. So what happens on this page is you have got this box here, which has got this area, which has got your inverters, and this column, which has got your panels. So I've chosen 3 panels, right? The 545 watts from Jinko, 470, and 465. This column here shows you the minimum length of a string, right? This shows you the maximum length of a string. And someone would ask, why is it that the 545s can allow you up to 18 strings, while the smaller ones only allow you up to 17 strings? The difference is in the voltage. Remember, normally what determines the string length is the voltage. So the 545 has got a voltage of around 49 point something, and then the 470s and 465s have got a voltage of 52 or 51 point something. So then that means their voltage quickly adds up. That is why they've got smaller, they can form smaller strings than the 545. But in terms of power, and probably if you look at it from a perspective of how much power you would need and the DC to AC ratio, it is much quicker to achieve when you're using 545 because you've got more wattage there. All right, so let me say, let's say I choose the 33CX there. I'm using one of that. Immediately when I put 1, it shows me that my total AC power is gonna be 33 kVA there. And in my summary table, the 33 is recorded there. Okay. Once I put that in, it also populates here. If you check on the panels, it populates here. It tells you that if you're using 545s, for 133 kVA inverter, you need between 86 and 109 panels. If you're using 470s, you need between 81 and 104. If it's 465, it's the same because 465 and 470 are very close to each other, so it doesn't really make much difference there. And this is the number of strings per inverter. As we said, it has got 3 MPPTs with 2 inputs per MPPT. Now, but we wanted to see, because remember, this is just a range of values between 81 and 104. We want to see if I were to choose 81, for example. Let's say, because 81 is for 470s and 465. Let's say I'm using 470, right? And then I put 81 panels. The system tells me immediately that this will amount to about 38.07 kilowatts peak on the panel side. And my DC to AC ratio is going to be this one here, 1.15, which I think is low, right? It's low. And here it has given me the actual string length if I use 81. So it tells me I'm still within the range, 14 panels per string, right? That is the smallest. But it allows me up to 17. How about if I increase them to, say, 85? My kilowatts peak have now increased. You can see I'm very close to 40 kilowatts peak, and my ratio has gone up here, right? I'm now at 1.21 DC to AC ratio. Right, so you can actually play around with the figures to be as close as possible to what you want. And then it also shows you right there the area that you need in order to install that kind of a system. So it helps you to discuss with your client to say, do we have any area around your premises where we can access 190 square meters? If not, what do we do? Right. So that is actually a very good kind of arrangement where you can actually see all the important factors when you're designing your system. Within a few clicks, you can actually see exactly what is going on. Right. So now I've just used the 470, and now let's say I now put 90 panels. For example, I put 90 panels. You can now see that my string length has gone up to 15. 15 is still within the range of 14 to 17, but there's a bit of a challenge in the sense that we are now going above the recommended DC to AC ratio. We're now at 1.28. Right, so it actually leads you to see certain limitations. To say, if I were to use 90 panels of this size, I'm gonna get 42.3 kilowatts peak, but my AC to DC ratio is now in a range that is above that. But of which with the 33CX is not a big problem, because we said 33 kVA is just a nominal. It can go as far as 36. Okay, so you can do some further maths if you want to make it go as far as 35 or 36, which are some of the highest. So 33 is just a nominal value. You can go above or below, but we don't recommend that you go too far above. All right, so this is just how you can see how easily you can actually adjust your system to match your design needs. Again, the area required will keep on showing there, and the length of rails will also be showing there. All right. We have done this. We've tested this configurator against one of the professional softwares called PVsyst, which we have here, to see that we have seen that it goes exactly the same. All right, exactly the same thing, the same results that you get on our configurator is what you get on PVsyst. So it's very, very reliable. We would want you guys to find your work easy. You don't need to go for a course to do some complicated software. You can just use this configurator to design your systems. Right, so now let's say I'm still using the same 33CX, but this time around, I choose to use the 545 watts peak panel. All right, the 545 watts peak panel, like I said before, it has got lower voltages compared to the 470s and 465s. Right, what it means is you can put more in a string of the 545s, but you easily reach the limits of the total kilowatts peak because of the size of the panel. Right, so that balance must be investigated very well when you're doing your design. You must investigate it very well to say, okay, it has lower voltage, I can put more of it in the string, but the wattage quickly adds up. All right, so let's say here they said 86,109, right? But let's put maybe the lowest one, which is 86 panels for the 33CX. What happens? You can see that your DC to AC ratio shoots over the roof. It's actually 1.42 at the minimum. All right? The DC to AC ratio is now very high. So you'd find out that sometimes it won't be ideal to use a certain size. So we would recommend that match smaller panels with smaller inverters rather than taking big panels against small inverters, because that will give you a very big headache in terms of design. So I would recommend that if you're using a 33CX, go for smaller inverters, smaller panels, because it gives you room to be within the acceptable ranges very easily. As you have seen here, if we just use even the minimum size, the minimum recommended number, your DC to AC ratio is already too high. Okay, but if we're to say maybe, let's say 80, for example, our DC to AC ratio is still high, 1.3. We want it to be around 1.25. So let's say 75 panels. Yeah, now it's finally round about there. Right, so you'd find out that it won't be ideal to be using a big panel against a small inverter. All right, so our recommendation is that go for medium-sized panels to small panels when you're dealing with a small inverter. When you're now dealing with a bigger inverter like the 110, you can now go for the biggest panels there. Right, so if you check even on my panels, I've got the 465. The only difference between 465 and 470 is the wattage. You can see dimensions are the same. So the 5 watts between the two won't really make a huge difference if you're dealing with small strings, which are very short. Right. So for example, if I were to say 81 panels, which we have here, you'd find out that the area would still be the same as the previous one because the dimensions are the same, the 470s, all right? And the kilowatts peak will only be a slight difference. If we were to choose 85, for example, you'd find out that it's more or less the same. The previous one was 39.9. This is now 39.5. So there's only a slight difference because of the 5 watts peak difference between the two panels, right? But these ones, you can easily play around with the DC to AC ratio until you are at a nominal value that you think this is ideal. For example, if we now put it at 90 panels, we're around 1.25, which we recommend most of the time. And the string length is 15. So with time, you would know that what is ideal for a 33CX, if I'm working 465 panels, is 15 panels per string. As you become more and more used to your designs, it will become very, very easy, right? So then we've got more features that we'll still be putting in as we develop this system. Remember, there's also an issue of temperature. There's an issue of temperature depending on where you are. The temperature conditions can have a very significant effect on your panels. For example, if you are staying in Northern Cape, or you're not the same as a person who is in Durban or Richards Bay, somewhere there, the levels of irradiation, the temperatures are not the same, right? So that is where we also have the functionality of you being able to choose the nearest city to where you stay. But that is something that we are busy integrating into our system there. With time, you see it working perfectly well, so that you don't end up designing a system that is working at boundaries or something that will fail once there's changes in weather conditions. Because remember, when you've got low temperatures, your panels perform at their very best. But when you've got high temperatures, your panels perform at the least. So it's very important for us to understand, guys, to say, if we say an inverter can take 18 panels or 17 panels as the maximum, you shouldn't be too close to the borders, right? In terms of your voltage. So for example, like if you have a string that has got 15 panels, all right, and you only leave a margin, of say 20 volts to the maximum recommended for that inverter. Like say you add up panels that give you up to, say, maybe 970 volts. The day it's going to be cold, those panels will produce higher voltages than on an average day. Now, what will happen is the voltages will add up because it's a string. And when they do, you're easily going to surpass the recommended value for your inverter. And probably that will end up in the damage of your inverter. And you lose your warranty and every other consequence that comes with that. So our designs must always be within a reasonable range or a reasonable gap to the maximum recommended and to the minimum recommended. Why? Because we don't want to have a system underperforming. We don't want a system being at risk of being damaged. All right, so that is the 33CX with those panels that we have put in there. So far, do we have anyone who has got a question? There are no questions. Okay, I just want to see if we can share something here. I cannot see an option to share my PVsyst. Okay. All right, let's just share my screen.
Just say window at window.
This window.
Screen.
Screen.
Yes.
Okay.
There we go.
Can you guys see this? All right. Okay. All right. So this is now a professional. This is now a professional software besides the one that I've shown you, which is our in-house tool that we have designed. I want you to see how close the values are. So before we do that, let me just show you the efficiency curve of the 33CX. As I was saying, there are three reference voltages here. There's the lowest voltage, 550. That is the one which is in red here on the graph. Okay. Then there's 585. 585 is here. It's in green. I think you can see that is the highest efficiency, right? And then the highest voltage, 850, which is the one in sort of grayish, which is it. So this shows you that at 585, you get the highest efficiency, all right? You get the highest efficiency no matter what output you are looking for here. That is why the green graph is on top of every other graph there. Right, so it doesn't mean that the highest voltage will give you the highest efficiency. Rather, it could lower your efficiency, right? And as low, if you're going very low, don't go below 550 volts. You might say, okay, 550. If you work exactly with 550, you find out that on a hot day, your voltages will easily go below 550 because voltage falls when temperatures are very high. So you'd probably, if you want, you'd probably work with around 600 and something volts, maybe 630, 620, so that if it falls on a hot day, you're still within the range of 550. All right, 850, why do we put 850 instead of 1000? Because we know this inverter allows you up to 1000. We are doing exactly for the same reasons that on a good day when temperatures are low, if our panels were to add up their voltages, we don't get the maximum value that is allowed. So this is just the efficiency curve that I'm showing you. All right. Now, let me just show you a small design using PVsyst. To show you that this tool that we have designed here is very, very close to what PVsyst does, which is a professionally designed software. Right. So here, I'll design a grid connected system, and I'm gonna use the 33CX as I'm saying here, and we're going to use a location called Lynbro Park, which is here in Joburg, as our. All right, let me just not generalize that. Let me actually explain this. All right, so with this software, what you can actually do is you can actually choose. You can actually choose a geographical location on a map like this one. If you know coordinates, the coordinates, it will be better. If you don't, it will still be fine. You can search by using the name of a place. Let's say Johannesburg. Right, so if you search for Johannesburg, this system will take you to Johannesburg. All right, you can then accept the selected point, which is Johannesburg there. After accepting it, you can import the data parameters of Johannesburg in terms of its solar behavior. Right, when we import, let's just wait a moment there while it's importing. Yeah, it is going to show us that. I think you can see from this table that these are values of kilowatt hours per square meter per given month. So it will show you that the highest, the month where you get the highest levels of production is in December, where you get 236.1, right? Followed by January, followed by November, and then October. But the lowest is around June. But that maybe to some people might look like a contradiction. But what happens is you are getting more radiation, but you also, in summer, you also have the hottest temperatures. So performance of your panels will go down because of the heat. But in terms of radiation, you are getting the best. So that is why panels perform better in lower temperatures than in higher temperatures. So here we have seen the trends per month of Johannesburg. Just save that. Okay. Then Johannesburg is our location that we have chosen. We can now go ahead and choose the orientation. We can go ahead and choose the orientation. There are two things here when you're looking at orientation. There's the tilt of your panels when they are on a roof. What angle are they at relative to the plane? Okay. And then there's the azimuth angle. Remember, azimuth is your angle relative to the south. So because we're in the southern hemisphere, our azimuth angle will be 0, 0. Right? If you're in the northern hemisphere, your azimuth angle will be 180. Right. So this tilt angle is the most efficient or the most productive when you're in Johannesburg. Why? Because we can see here losses with respect to optimum is 0%. If, for example, I increase the plane tilt to 34, you can see my losses are beginning to increase. All right. If I do the same at 50, my losses are even more significant. If I put the panel too close to the roof like this, I've got very, very huge losses. Why? Because there is no ventilation to my panel, right? So let's go back to the most productive angle, which is around 29:30, somewhere there. 29 degrees and 30 degrees will both give us 0% loss. All right, so we accept our orientation to be fine. We say, okay. Here we now define our system. At this stage, we now define our system. This will ask us, there are so many things that you can use to design. So let's say you have chosen that you want to design, our previous design on the spreadsheet was 41.485 kilowatts peak, right? So if I put here the planned power at 41.85 as my planned power that I want to install on that system. That will make my work easier. Then I can choose here the PV module, which brand I'm going to use. In this case, we are using Jinko Solar. It's here. We're using Jinko Solar. Which size are we using? Let's use the 465 that we used in the previous example on our spreadsheet. 465. Immediately, it shows me 202 square meters is needed here to install enough panels for that project, which is exactly very close to what we have here. I don't know if you guys can see it. 202 is on our spreadsheet. If you go back to PVsyst, it also says 202. So it shows you how accurate this thing is. All right, let's go ahead and now say, what is the inverter that we want to use? It's still SunGrow. Choose SunGrow there, and we want to use the 33CX. Okay. Now, this part is very important. You can see there's a warning here, which says the inverter power is slightly undersized, which means our panels are slightly higher than the recommended power, which is exactly what I explained before here. Our ratio has gone beyond 1.25. It's now 1.26. What if I were to reduce my panels to about 85, for example? What do I get? I get 39.525 kilowatts peak. Let me use 88. All right. Yeah, if we use 88, we get 40.9. So let's put that into our PVsyst. All right. It's still showing us that we have got a bit of an error there. So we need to reduce it a bit again. Let's just work with 85. All right. Our DC to AC ratio is 1.19. If we come back here, we get 39.525. Let's put that here. 39 point, let me use 5, 39.5. The error is actually disappeared. All right, so you can see here, you can see the error has disappeared. So the most ideal design would be to use how many modules? 85 modules. Do you see here? This system actually shows you 85 modules. Our spreadsheet shows you 85 modules. What is the DC to AC ratio? Here, 1.19. If you get to PVsyst, it shows you 1.20, which is very close, right? Square meters, 191 on the PVsyst. On our system, it's 190.8. Very, very close. Right. Then when you have done that, this area you see the recommended modules and string configuration. So they've recommended that let's use 17 modules in series and have 5 strings, meaning to say there's one input that they are not using there. Right? They're going to use in total 85 panels, just like us. But they have chosen to use 5 inputs instead of the total of 6. But with us, we have chosen to use all the 6 inputs. That is why our string lengths are not going to be 17 per panel per input. They're going to be 14 because we are using all the 6 inputs. That is the difference between our design and their design. Right. So our design will give you 14 panels per string with 6 strings, right? If you do the same multiplication, you get 85, right? If you come to these guys here, they've chosen to say, let's say have 17 modules per string with 5 strings, which means the other string is not used. Right. So these are just differences in terms of what they prefer and what we prefer. But in terms of the results, you get the same results. All right. So we wanted to show you guys that designing a system just in a moment doesn't require you to buy the most expensive tools or anything. They do more or less the same as what we have designed here at UDECO. So that tool, guys, I think as you have seen there, is a very, very useful tool. It gives you a summary here, gives you a summary there, which is more or less what they have here. Check the number of modules, 85. What do we have? We've got 85, right? Check check the module area, 191 square meters. We have got 190.8, which if rounded off will be on 191, right? Come and check the nominal PV power. Theirs is 39.5 kilowatts peak. Ours is also 39.525. Check the output nominal power, 33.0 kilowatts AC. Ours is also 33 kVA AC. Right. And then the AC to DC ratio, 1.198. Ours is also 1.197. Very, very close. I think just for the simplicity of your work, this is the kind of tool to use, guys. As I have said, this is a work in progress. We keep on updating our system and making it better and better. It will include more and more functionality. And very soon, we'll put it on our website so that if you're a designer and you just choose that I want to buy from these guys, you can easily go to our website and say, I'm planning on having this size of a plant, and this is the size of panel that I want to use, and this is the inverter that I want to use. You click, you choose the number of panels, you choose the number of inverters, and automatically our website will calculate everything for you. It will show you the fuses, the number of rails that you need, the minimum area that you need, the cable size that we recommend, the length of cables that we recommend for that particular project. All in one. That is what we are planning on doing. So we'll do more and more designs as we move on, trainings on designs, so that you guys can find it very, very easy. You don't have to spend a lot of time on doing designs. Okay, most of your work must be done on installations. The designing work, mostly it can easily be done on our system. And of course, there are times when you might just need some very, very specific calculations when you get to the premises. But we've designed this to try and make sure that the majority of the work is very, very easy for you. All right, thank you, guys. Can I leave this time to those who might want to ask questions?
Thank you, Eden. Yeah, this has been great. Just to attach to what Eden has been showing you guys, we are busy building. While its first phase is completed on the configurator, it's an online configurator. If you had a look at our website promotional video that we posted the other day on LinkedIn, you would see that we've developed the configurator in a similar fashion to the Excel. It's just much more stepped entailed, where you can go step 1, you select your region, step 2, you'll select your inverter, step 3, you'll select your panel, and then it will automatically calculate the rest of the details for you. And as per Eden's showcasing, we are more accurate essentially at the end of the day with the amount of information that we pull through. The PVsyst system actually rounds up your numbers or rounds them down. And as per our systems, we have exact numbers, so you have exact calculations going towards you. Another nice feature that we're building on the configurator is that when you've selected out your configuration, you can actually take it and add the products into your cart, and you'll be able to check out from there. So you'll get a price estimate and all of those informations from there as well. But let's give a couple of minutes to the guys to ask any questions if they have. But thank you, Eden. It's been really informative, and we'll go along and do more of these, are we?
Thank you so much, Daniel. Of course, we'll have more and more sessions, and please feel free, guys, as our clients, to raise any issues that you'd want us to attend to. If you want a training on something else, we have got those sessions coming. We've planned our year to say if you are in need of any training at site, on your premises or somewhere else, or if you can come to our offices, we are free. We can tell you when you can come in, then you'll be able to benefit and share ideas with us, and we'll share our ideas with you, and also show you how to best make use of whatever we have at our in our systems to benefit you.
Definitely. There is a page on the website if you guys want to go have a look. It's called Events. All of the previous recordings are on there, listed on YouTube, and all of the upcoming webinars are also listed on there where you can register. With regards to other training sessions, we are happily taking requests. So if you have a request of a training session, please email quicksupport@hedaikaenergy.co.za, and we'll be able to arrange something for you there. But thank you, guys. It seems like there isn't any questions for today, and have a good weekend.
Thank you, Daniel.
Thank you, guys. Bye-bye.